4-9 scientific notation.
All right, today's objective is to use scientific notation to write very large or very small numbers. So scientific notation is kind of like a standard form. It's like it said, like the objective said, it's used to write really, really large numbers. Like we're talking the weight of the sun, or how far it is to another galaxy, or really, really small numbers like the weight of an atom, or if we're talking big numbers, how big your mom is, or something like that. So really, really big numbers, okay? So the standard form is for a times 10 to the b power, where 1 is smaller or equal to a, and a is smaller than 10. So what that is basically kind of saying is it needs to be 1 or bigger. So the a has to be bigger than 1, but smaller than 10, although it can be equal to 1. And b is any integer, and that means positives and negatives. Do you remember doing positives and negatives?
Yeah.
We talked about that a little bit when you helped me with one of my other lessons. Okay. So here's some examples. This would be 6,320,000,000. Now really that's not a big number when it comes into the scheme of things, but for our purposes it's pretty big. So basically what you do is you find the decimal point. Do you know what a decimal point is?
No.
Okay, decimal point is it deals with fractions, which you're just kind of starting to deal with. So if you don't see the decimal point, Gabby, it's always at the end of a number. So that means it's after that last zero. So I'm going to plug in a decimal.
That's an equals sign.
Yeah, well, so what I'm going to do is I'm going to put one in there right there.
Mm-hmm.
So you see that decimal point?
Yeah.
So now I want to move the decimal point to where it's behind the first digit that's not a zero. So looking at that number from left to right, like you're normally reading it, where's the first digit that's not a zero?
The 2 and 320.
No, now remember, we're going from left to right. So left, we're going this way.
So it's 6.
So right, so the 6 is the first digit that's not a zero. So we're going to move the decimal point over to behind the 6. And we're going to count how many places we moved. And we moved 3, 4, 5, 6, 7, 8, 9 spots. So we're going to move 9 spots. So we jumped 9 spots to the left. So we would write this as 6.32 times 10 to the 9th power.
Wow.
Okay. So now let's look at the next one. Down below that, I'm not even sure. Let's see. That's tens, hundreds, thousands, 10,000s, 100,000. So that's 27 millions. That's something that's really, really small. So do you see where the decimal point is?
I don't see a decimal. Oh, the decimal point
is... It's after that first
It's
zero.
after this first zero.
Okay, so now we want to move it so it's behind the first non-zero digit, going from left to right. So where are we going to move it?
I would say behind the 2.
Perfect. Absolutely right. So we're going to take it, and we're going to move it 1, 2, 3, 4, 5 spots. So we jumped 5 spots to the right this time.
So it's 0.0.
No, we drop all those zeros, and the decimal point moves, so it's going to be 2.7 times 10. Now it's going to be to the negative 5th. So small numbers are going to have a negative exponent. Big numbers are going to have a positive exponent. What, Cruz? You want to be in? No, climb around the other end and climb down underneath. No, Cruz, underneath the table. Climb underneath the table and come up. All right, we got a special guest here. We got Cruz. He's joining us. So hopefully squeeze in here, Cruz. And we're talking about scientific notation, and it's used when we're doing really big numbers and really small numbers. All right, so that would be our answer for small number. So we're going to, bottom line, what you need to remember, when you're changing to scientific notation, when you jump to the left, the exponent is going to be a positive. And when you jump to the right, the exponent is going to be a negative. So here's a large number. That's 77,250,000.
And that is 8 billion.
And that's 8 billion, you're right. So, Gabby...
Looks like way more than that, but that may be more than that.
No, 8 billion is more than 77 million. Okay, billion's bigger. All right, so Gabby, do you remember, if you don't see the decimal point, where's it at?
It's supposed to be at the first number that's not a 0.
No, but before we do that, that's where we're going to move it to. But if you don't see it, where does it start out at?
The right side?
It starts at the far right, absolutely. So if you don't see it, it's at the very end. So now we need to move it to the left because we want to move it to the first digit that's not a 0, or behind the first digit that's not a 0.
That's 7.
That's the first 7, right.
First 7.
So how far did we move? We moved 1, 2, 3, 4, 5, 6, 7. So we jumped 7 places to the left. Now if we're to the left, is that going to be a positive exponent or a negative exponent?
Positive?
Very good.
It said positive too.
You both did, yeah, jinx type of thing, right?
Yeah.
So we're going to write 7.725, then we drop all the zeros, because that's kind of the point, is to make it easier to write, times 10 to the 7th power. Okay, now I'm going to write 8 billion as a regular number, so that would be 8 with 9 zeros behind it. So Cruz, if you don't, so now we need to find the decimal point. If you don't see the decimal point, Cruz, where's it at?
Right at the end.
It's right at the end, so there it goes. It's right there.
And we have to make jumps. It's probably more than that.
It probably is. So we're going to move it there because that's behind the first non-zero, right?
Mm-hmm.
Yes.
And let's count how many we moved.
1, 2, 3, 4, 5, 6, 7, 8, 9. I knew it was going to be 9 because you said that there was 9 zeros behind
Very
the
good.
number.
Yeah, you're right.
Oh, yeah.
Okay, so how
Let's
would we
grab
write this?
Abby.
You guys know how we would write this?
I don't know.
No.
Okay, so we can just put the 8. We don't need to put any zeros. We could put 8.0, and I don't remember what I did, but so
It's 8.0.
8.0 times 10 to the 9th power. So however many jumps we are, that's what our exponent's going to be. Okay.
Cool.
So let's practice a couple small numbers. So we see the decimal point. So where are we going to move the decimal point to? Do you think you know, Cruz?
To the first.
Gabby?
That one. Probably. I think it's going to stay at the end.
No, it doesn't go all the way to the end. It goes behind the first non-zero digit.
Which is the 9.
Very good. So we're going to move it to behind the 9. How many spots did we move? 1, 2, 3, 4.
4 jumps right?
4 jumps to the right. So that means our exponent's going to be
4.
a 4, but it's going to be a negative 4. That shows.
We haven't. In my class, we haven't learned negative numbers.
No, you haven't learned negatives yet. I think
You're
you
not
learned that in
gonna.
5th or 6th grade. So, all right. So that would be our answer. 9.03 times 10 to the negative 4th. The negative tells us it's a small number. All right. So for our next number, Gabby, where are we going to move the decimal to?
We're going to move the decimal to the first non-zero number, which is the 9.
Okay, it's the only.
It's going to go at the end.
Yeah, it's going to go at the end.
And
So let's count 1, 2, 3, 4, 5, 6. We're going to move 6 jumps to the right.
so it's going to be, I think it's a negative 6.
Very good. So it's going to be 9 times 10 to the negative 6. Okay? And that's our answer.